These documents outline the primary threats to rangelands that we can address through voluntary conservation or through farm bill investments. So we've got woodland expansion, invasive annual grasses, land use conversion, and riparian and riparian meadow degradation. So over the next few slides, what we'll do is I'll show you just how much woody expansion is changing our rangelands and why it's an issue. And just a note on terminology, I might use the terms conifer expansion or conifer encroachment interchangeably with woody encroachment, but I'm using all of those to refer to an increasing number of trees in what are historically treeless ecosystems. So this is what woody encroachment can look like. This is a set of photos from Southeast Montana. And over this 50-year period, you can see that the trees that were typically confined to the draws have crept into the adjacent rangelands. And these images show that it only takes a couple generations for a system to go from being fairly open to more enclosed with significant losses in rangeland systems. And this type of change isn't just isolated to a few places. It's a growing issue across the northern Great Plains and the Intermountain areas. And it impacts both ranch economics and rangeland health. So before we dive into those impacts, I want to show you the scale and rate of change that we're measuring this across the West. So tree cover is increasing on approximately a quarter of all rangelands in Western US. All the areas in green that you see here are places where we've measured an increase in trees over the last 30 years. And the darker the green, the bigger the increase. Tree cover is increasing by about 630,000 acres every year. So for context, that's an area about the size of Yosemite National Park. And over the past 30 years, rangeland loss to woodland conversion has totaled an area nearly the size of Iowa, and that figure is projected to approximately double over the next 3 decades. So let's take a quick detour to the southern Great Plains because what's happening there shows just how quickly trees can transform a biome. And already on much of the grasslands in this region, it's transitioned to woodlands. So on this map here, green represents intact grasslands, the yellow is a transition zone, and red represents the eastern forested biome. And these maps give you 4 snapshots from 1990 to 2020. And I'm going to put a line here, which represents the same location in each of these maps. So what you can see is that the woody biome is creeping westward and northward. And back in 1990, we only had problems in Texas and Oklahoma, but now we're seeing the woody biome spread into Kansas and Nebraska and beyond. And they're finding it's harder and harder to maintain those landscapes as tree-free. So places like Oklahoma are dealing with declines in forage production, water issues, wildfire issues now, and even increased in prevalence in tick-borne illnesses, all because of the growing number of trees. So what's driving this change? Oh, for one, land use legacies have played a role in some places. Historical overgrazing facilitated shifts in vegetation that favored woody species. Then we've got increasing carbon dioxide, which gives trees a competitive advantage over grasses and forbs. Atmospheric change increases tree growth more so than it does grasses. It also enables trees to use water more efficiently and establish in environments where they would have previously been water limited. And that leads us to drought. Trees have the ability to use deeper water sources than forbs and grasses, which makes them more resistant to drought. Probably the most dominant factor, though, is fire suppression. Historically, more frequent fire return intervals restricted trees to the margins of grasslands and shrublands. But ultimately, all these factors interact to make conditions more conducive to trees to colonize previously treeless rangelands. And before I go on, I do want to make a distinction between expansion and infill. So these terms are often conflated, but really they're two separate issues that require different management strategies. So woodlands occur across a diverse continuum from systems where trees are dominant, like primary forests, to systems where trees are co-dominant with shrubs and grasses, like savannas and wooded shrublands. And on the other end of the spectrum, we have our tree-free grasslands and shrublands there. And many woodland systems have experienced increasing density of trees, which is what we refer to as infill. And infill can negatively impact forest health, but that's not the issue that I'm discussing today. So instead, when I refer to conifer expansion or encroachment, I'm specifically referring to trees establishing into formerly treeless systems, like these open grasslands and shrublands. And as trees, colonize grassland and sagebrush systems, we begin to see really negative responses from the wildlife that occupy these landscapes. Sage grouse are, the classic example. Even low levels of encroachment can have outsized impacts on this bird. Sage grouse abandon leks in areas with as little as 4% tree cover, which is really only a handful of trees per acre. And science has demonstrated other negative impacts to sage grouse demographics, including mortality risk, low population growth rates. And encroachment can also be bad for big game. Recent studies that have just come out have shown negative impacts to food sources, offspring survival, and adult body condition. Similarly, grassland songbird abundance and reproductive success also declines when more trees appear. And I could go on. There's lots of impacts on wildlife. So there is a growing library of research demonstrating that woody encroachment is bad for grassland and sagebrush critters. And our Working Lands for Wildlife website catalogs much of this science. So I would encourage you to explore that resource if you want to learn more. And wildlife impacts aren't the only concern, though. We have also been developing science showing the impacts to ranching operations through changes to forage and water. Here, invading trees can reduce rangeland production by as much as 75%. We maintain the national rangeland statistics on losses to productivity due to woody encroachment, which you can find at the website at the bottom of the page at Yield Gap. You can access statistics at the state and county scales here on how production is changing through time in response to encroachment. So, for example, in 2022 alone, the Great Plains lost close to 12 million tons of rangeland production, which would make enough round bales to stretch 3/4 of the way around the Earth. Or enough forage to feed 2.5 million cows per year or for a year. And over the last 3 decades, this ecosystem shift represents millions to billions of dollars of production and revenue loss to producers. We also have the ability to look at how trees impact forage production at the individual ranch level. And I'm going to do that using a case study from a typical Montana ranch located in the southeast part of the state. We saw these photos earlier, but I wanted to pull them up again because these are taken from our case study ranch, and I wanted you to recall how much tree cover has changed on this ranch over, a relatively short amount of time. So about 15% of this 11,000 acre ranch has been encroached at this point, and we can already measure the impacts to forage production. So here the plot on the left shows how tree cover and forage production have changed over time on this ranch. Over the last 30 years, trees have more than doubled, while forage production has, subsequently declined. And they are currently losing about 600 AUMs every year. And the table on the right side illustrates how putting off treatments quickly accumulates forage losses and puts the long-term productivity of this ranch at risk. So let's assume 1990 conditions as our baseline. If this 11,000 acre operation had treated emerging trees in 1992, they would have prevented the majority of today's forage losses. The investment at that time would have been approximately $342,000, but spreading this expense over 10 to 20 years and leveraging available cost share programs like the NRCS EQIP program could have made it more manageable for the producer. But today, if you tried to return that ranch to 1990 conditions, it would cost over $1 million, and they've already forfeited 30 years of production on those acres. So if you wait another 30 years from now, and the cost will quadruple. The fundamental takeaway here is catch encroachment early, or you end up paying exponentially more later through cumulative forage loss and escalating treatment costs. All right, so now let's look at how encroachment impacts water. So we used to assume that trees like grasses and forbs went dormant when the soil dried out. And under that assumption, trees were not impacting groundwater. But what we're learning now is that trees have the ability to access deeper sources of water. So instead of shutting down during the dry, hot parts of the summer like forbs and grasses do, trees continue to use the water, drawing from the deep groundwater that supplies streams and irrigators. So every new tree on the rangeland is another straw contributing to long-term impacts on groundwater recharge and stream flow. And as droughts become more frequent, protecting groundwater and stream flow is going to be more important for the communities and producers that depend on them. So managing that encroachment, keeping the grasslands and scrublands open is one of the most direct actions we can take to keep water in our streams when it matters most. Remote sensing tools now allow us to measure how increasing tree cover changes the water used by vegetation in a system. It's really cool. So this is data from the Alder Creek watershed located in the South Tobacco Root Mountains of Montana. And on the y-axis, you'll see the percent change in vegetation water use. And on the x-axis is the change in tree cover. So the main takeaway here is that the greatest changes in water use occur early in the transition from an open system to a wooded system. There's actually not much change in water use once the woodland is established. So we're not really going to regain much water to the system by thinning a forest, say from 50% down to 20%. However, when we maintain open grassland systems or restore them by removing all the trees in that low encroachment area, we maximize our water savings. So in a hotter, drier future, there's a lot of uncertainty about what the future holds regarding water management issues. Conifer management is one of the easier actions we can take collectively to mitigate some of these uncertainties with water scarcity in the future. For example, here in the Smith River watershed in central Montana, home to one of the state's treasured rivers with renowned trout fishing, they've lost about 133,000 acres of rangeland to encroachment. And we can look at woody encroachment water use as a percentage of annual discharge in the Smith River. So the amount of water that this watershed is losing to woody encroachment is equivalent to about 18 to 20% of the water flow in the Smith River. Restoration could return about 30,000 acre feet of water to the system every year. This is roughly the same amount of water used by every irrigator in the watershed combined. And I do want to be careful here. We can't guarantee that clearing out all the encroaching trees will have or will necessarily translate to higher river flows, because the water moving through these tree systems is super complex. Restoration might improve late season flows to support river recreation and trout population and irrigation. At the very least, though, managing woody encroachment could be an important drought buffer during dry years. So now that you've seen that woody encroachment can have a very significant impact on wildlife and forage and water, um, but because of the scope and scale of the issue, we can't get ahead of the threat with the traditional random acts of conservation. Instead, strategic targeting of treatments where they will be the most effective and durable long term is how we need to maximize conservation outcomes. So understanding how encroachment progresses across the landscape is key to success, which is shown in this figure here. On the far left, we have open, intact grasslands in green. Then areas within the seed dispersal range of the conifers are what we call our vulnerable areas, or places where encroachment will occur next. And then as we move further right, encroaching trees become more mature and dense until they effectively transition to a forested system. And we classify these into three phases based on the density of the trees. And we found that preventative action in vulnerable or phase one rangelands is the most effective and economic strategy for dealing with encroachment. A little bit of work now in these areas can go a long way in preventing encroachment from progressing to that point where it steals the water and forage resources. And as encroachment reaches the advanced stages, the cost to producers can increase exponentially because of the equipment needed for restoration. And all the while, forage and water losses continue to accumulate. So a preventative, proactive strategy doesn't just apply at the ranch level, but also to how we want to approach this threat at the biome scale. Our science is telling us that the most cost-effective and strategic areas to concentrate our efforts right now is in the northwestern Great Plains that you see circled there. So in Montana, Idaho, Wyoming, parts of the Dakotas. These are the places where we can make the most difference by scaling up management to address encroachment across the entire watersheds before it really takes hold. And to assist land managers and landowners in this region, we led the development of a technical guide and some other products that detail how to approach this threat. And that's what we'll cover in the next couple of slides. Right. So conifer encroachment, definitely isn't a new problem. People have been fighting conifer encroachment over here in the Great Plains for decades, and their efforts can teach us a lot about how to effectively battle encroachment in this northwestern Great Plains region. So these two documents that you see were written for the Central and Southern Great Plains, the Woody Encroachment Vulnerability Guide and the Grassland Woody Encroachment Pocket Guide. And they lay out sound science-based strategies for selecting the best areas to work and the right treatments for various stages of encroachment. But when these resources came out, people up here in the northwestern Great Plains region started to use them, but the imagery and the landscapes and even the dominant conifer species were just different enough that folks in this region wanted something more regionally tailored. So our goal when we went into this was to create a similar set of resources, but make it specifically for the northwestern Great Plains. All right, so the first thing we did was we brought together a co-production team of university researchers, NRCS state rangeland specialists, and the Working Lands for Wildlife team at the University of Montana. And we put together a family, call it, of regionally specific resources designed for that part of the Great Plains. And here's what we've developed. A set of resources, each specialized for use in different areas of planning and outreach. So first on the left, we've got the technical guide. This details the ecology and history of conifer encroachment. It includes regional landscape scenarios with ground and drone imagery. It walks through a framework for mapping and prioritizing treatment areas. It's kind of dense. It's more of call it a desk reference. For use in the field, we've got the 4x7 laminated pocket guide down there at bottom center. It's similar in scope, uses the same imagery, but has less text to get bogged down in. It's designed for use on the ground. So NRCS staff and landowners can flip through it quickly, find landscapes that look like what they're seeing on the ground. We think this will be a really useful in starting that conversation with landowners. We also developed the two-page fact sheet on the right called All Trees and No Cattle. This one highlights those economic costs of encroachment that we covered, and talks about how delayed treatment costs will escalate, and it uses that same 11,000 acre Montana ranch as a case study. And finally, we've put all of these materials and more at coniferencroachment.com website, which is what you see there, top middle. So we'll go through a couple shots of each of these guides and resources. So these are pages from the technical guide. What we want people to understand is really the ecology of encroachment. We talk about the ecological succession from open rangelands to a closed woodland. We explain how to apply the concepts of vulnerability and risk management, and how understanding that ecology is critical to planning and decision making. In that, we cover 11 different landscapes and scenarios where encroachment is occurring. We talk about the difference between rangelands and woodlands. We talk about scenarios like rocky outcrops, like you can see there from Wyoming. We've got the moraine pothole area in Montana. We also talk about riparian areas, how they can be like a highway for encroachment, for trees to sneak under the radar. And then on the right, you see windbreaks. Here's an NRCS practice that can actually be an unexpected seed source and lead to future problems. Here we see the opening section of the pocket guide. It's organized into these chapters that you see. We've got key concepts, encroachment scenarios, the strategic framework that includes defend the core. It covers some tools and techniques, and then it goes into the planning process. Each section of the pocket guide has a color band, like you see there on the edge of the page, so it's easy to flip through and find each section that you want while you're in the field. In the strategic framework section here, we emphasize reducing vulnerability and risk. So it's not just about cutting trees. We talk about how the presence of trees is the greatest predictor of where encroachment is likely to occur next. And just for example, a single seed-producing tree with the modest dispersal range of 200 yards can compromise 26 acres of rangeland. So that's how you kind of judge vulnerability and risk. So that translates to managing seed dispersal and recruitment and focusing the effort where it will have the greatest long-term benefits. We also introduce here the defend the core model. You might have seen the medical analogy before, where preventative care is far more effective and far less expensive than emergency medical intervention. So the same principle applies here. And in both of the documents, the pocket guide and the tech guide, we go through a step-by-step planning process to maximize outcomes. We walk through how to move from a broad treatment polygon, say a ranch boundary, and go through steps to develop a detailed, spatially explicit map of encroachment stages and vulnerabilities. And with that, the goal is to move from, a general idea of we need to cut trees to creating a prioritized, mapped plan of action. And here's the 9 steps we came up with for building what we, refer to as a spatial game plan. First, we've got assess the landscape context. We want people initially to zoom out and understand how their site fits into the broader environment. Ask the questions, where am I in relation to core sagebrush areas? Are there seed sources outside of my immediate vicinity? That kind of thing. Second, Inventory and map the encroachment stages. So that's all of the different phases from grassland to encroached woodland. Third, identify special high value areas like, sage grouse leks or riparian areas or wildlife migration corridors. Fourth, determine social and administrative capacity. Do you have all the necessary permitting? What about possible partnerships? Do you have all your neighbors on board? Do you have funding? How can you get funding? Fifth, refine your project area and goals based on what you've learned in those first steps. Sixth, integrate special considerations. Here we want to talk about or think about, what's the risk after conifer removal of invasive grasses coming in? What am I planning to do to deal with that threat? Stuff like that. Seventh, we create the prioritized plan covering every acre. Even acres with no trees need to be part of the plan. That's really important. Eighth, implement and evaluate. And ninth, build coalitions and expand your impact because long-term success happens at these landscape scales and not just in a local ranch. So when you put it all together, you might end up with a map something like this, broken into the encroachment stages and vulnerability levels. We've got high value areas delineated. That dot in the middle represents a grouse lek. And each of these units is tied to a treatment priority consistent with that defend the core approach. So once you've got this, your actions become strategic and proactive rather than reactive. All right, to wrap up, here's just the key ideas we hope people take away from this. Conifer encroachment is a leading driver of rangeland degradation with serious ecological and economic consequences. Exposure, meaning that proximity to seed sources, is one of the strongest predictors of risk. The most cost-effective strategy is to anchor to and defend intact core rangelands that are already treeless. And finally, collaborative landscape scale efforts dramatically increase capacity, reduce costs, and improve outcomes. So again, you can find everything that we've talked about at coniferancroachment.com. I'm guessing Greg has put the link in the chat, but this QR code will take you directly to the site where you can download these guides. For physical copies, send requests to your NRCS state range management specialists in that Northwestern Great Plains region. And I guess thanks for your time. I really hope these resources are helpful in your work. And we'll go back to Kelly to handle questions and discussions.
Perfect. Great job, Derek. Thank you so much.
My pleasure.
We, just so that you're not having to hunt who that specialist is in your state, in the follow-up email that will have the reporting, we'll include that in there as well, of who you can reach out to with their email address. Okay, a couple of questions. First, Derek, how do you determine your baseline of where woodlands should or should not be?
That is a great question. Thank you for asking that. There's no real right answer on this. What we recommend to people is using a tool called Landscape Explorer, which will show you imagery from the 1950s and compare that to today. That's what those side-by-side images from Montana were based on. That's a pretty decent starting point. You might have some ecological discussion about that, but it's a good place to start. You can also, especially in the Northwestern Great Plains region, you can do soil tests. And if you look at the soil profile, it can leave clues about if the site was, somewhat recently a grassland and has converted, or if it was always a woodland. I hope that helps.
Perfect. Next question. What is the longevity of treatments and what should follow-up solutions after that be?
Yeah, another good question. It totally depends on a few different factors, and that could be, how much precip you get, what species you're dealing with, what's their seed dormancy, that kind of thing. But typically, when we go through an initial treatment of a mature woodland, those can pop right back up, and you're looking at retreatment again rather quickly. But if you stay ahead of the game and you're treating those areas at the beginning phases of encroachment, if you knock those back and deal with seed dispersal effectively, then you're buying yourself a lot more time. But yeah, if you go in and hack up mature trees, the seeds in the ground are going to pop back up, and you're looking at possible retreatment, serious investment over the next 8 to 15 years, maybe. But the trees are going to come up. So what we do recommend is that after treatment, you just start a monitoring program and you look for those little trees as they come up. Keep your loppers with you and cut them back as quickly as possible.
Great. This is great information. Are there any other plans for other ecoregions, or is there something that already exists?
Good question. Yeah, so we talked about there's that set of resources for the Great Plains already. These new ones cover the northwestern Great Plains, and we've started work. Our next ecoregion is going to be the Great Basin. Started work on that this year, and hopefully we'll have resources out for that this winter. And then beyond that, we might go south, like into the Colorado Plateau, the following year or years. But do keep in mind that even though the landscapes and species might change, the strategy and the approach and all the tools and everything is pretty much the same wherever you go. So these resources will work for you. They just don't look quite right.
Perfect. And we got a question that was, are you planning on developing the tech guide for other regions of the West?
Yep, same thing. I'm glad there's interest for other regions. That's wonderful.
Perfect. What are some of the best outreach methods to ranchers and landowners that you have learned to address with this issue?
Ooh, that's a good one. And I wish Shay was here. She is really on top of that. Um, it depends on where you are. Like we do a lot of field tours, and we've got a social media presence. That's a tough one. You got to work on making inroads. Yeah, maybe Kelly and the comms team. Do you have any ideas?
I think what you said is great. Working with your local groups. I think that that's one thing that Shay has had great success with. She finds local groups that are willing to, hear what she has to say and see her presentation. And so, different groups in Montana have invited her to come and speak. And I think on a local level is really important, trying to get peers of ranchers and farmers that they respect, that can say, hey, these people have something good to say and you need to listen, is probably one of the best ways to get a lot of people in a room at once.
Yeah, and I see Greg's comment. If you can get someone to look at Landscape Explorer, that is a great tool to start the conversation. Probably the hardest part is to engage with people that don't see the problem yet. Like we're trying to get ahead of it, and it's not on their radar. It is a lot easier to talk to people where it's already a problem. But yeah, Landscape Explorer is a wonderful starting tool. Thanks, Greg.
Well, great. Well, thank you all for attending.